Okay, there we go. All right, here we go. All right, hello everybody. My name is Greg. I'm from GregsTutoringNYC at gmail.com. It's ELA day. Just making sure I'm coming through here, and yes, I am. Okay, good. Okay, so I finally got this working. All right, let me get rid of that. Again, my name is Greg. I'm from GregsTutoringNYC at gmail.com. You can check out my email if you have any questions for me in the path here. It's one of the few days I don't have tutoring because it's the second day of the ELA test. So everybody's just taking it easy. So what I want to kind of do is merge two things at once. So what we're going to be doing is doing a few videos covering grade 7 and grade 8 math of New York State. At the same time, I want to cover kind of what's pre-SHSAT. Because I get a lot of people asking me questions about grade 7, grade 8 math, and I get a lot of people asking me about the SHSAT, which is the specialized high school test for things like Brown Science, Brooklyn Tech, Stuyvesant, Brecken Latin, Britain, Lehman, City College, York College, they're all the high schools there. And they often want to know what the topics are. So this video is not going to address this. I've already done some videos addressing that, and I will do some more, I guess, pertaining to that. But what I wanted to kind of do here is kind of back off both of the two different things, which is grade 7, grade 8 math, and back off the SHSAT, and kind of do a simple level bunch of videos just covering some of the topics, just so people can get an idea. I'm going to use the interactive sampler that New York State provides and go through some of those examples. So maybe there's, I don't know, 50, 60, 70 examples we end up going through in maybe 6 or 7 videos. Again, so that's what we're going to do. So let me try to switch into the sampler, and I played around with it a bit, so I hope I know how it uses, and we'll just maybe do some tweaks along the way, trying to fit it onto the screen and so on, things like that. So what I'm going to do is put me into the corner, and we'll just jump into some of this stuff here. Okay, so the first question is, a recipe requires 1/3 a cup of milk for each 1/4 cup of water. How many cups of water are needed for each cup of milk? There's a few ways to do this. Let me try to just bring up a pencil thing here. That's going to be that. Okay, so we have a 1/3 a cup of milk, a 1/4 cup of water. They want to know how many cups of water are needed for each cup of milk. So what we're going to do is relate them. We know there's a 1/4 cup of water for each 1/3 a cup of milk. Okay, so we can either do that just logically. If it's a 1/3 to a 1/4, right, and they're saying this is a 1/4 here, how many cups of water are needed for each cup of milk? Well, if we're already told there's only a 1/3 a cup of milk, to get a cup of milk, we need 3 times that amount, right? So that means we need also 3 times the amount of water. And if there's already a 1/4 cup of water, then 3 times that amount is 3/4. So in that case, the answer would be B. Okay, let me get this pencil out of here. Okay, let's see. How do I remove? So that would give us B here. Okay. There's also kind of a second way to do it, which is just set up ratios. Okay. So if we have, just give me a second till I get this tool thing going. Okay. So if our situation is going to be milk is to water. Okay, and this is also symbolically the same as milk is to water. We can write it as that same way. So if we get milk, which is a 1/3 is to a quarter. Actually, I did this backwards. It's actually water to milk. So we would end up with water to milk. And the ratio being water to milk. Okay? So that would mean this would be flipped. We would have a quarter over a third. So if you notice, we have a fraction divided by a fraction. So we can write that out longhand, which is a quarter divided by a third. And if you remember the rule, if you have division by a fraction, it's the same as multiplication by its reciprocal. So we end up as the 1 here times the 3 here. So that's equal, and we get 3. And then we had the 4 here times the 1 here. So that gives us 4. So we get 3/4. Okay. Okay, so let me get rid of this other part here, and we can go to question number 2. So this is regular thermometer kind of questions. These come up often enough. Just give me 1 second. I want to make sure this stream is still going. The question is, yesterday the temperature at noon was 11.4 degrees Fahrenheit. By midnight, hello everybody, my name is Greg. I'm from Greg. All right, this is not going in sync with us here. All right, okay. Let me just give me 1 second. All right, it's close enough in sync. Okay, so the temperature at noon was 11.4 degrees Fahrenheit. By midnight, the temperature had decreased by 15.7 degrees. What was the temperature at midnight? So there's a few ways to do this. We could do it as a thermometer. We could do it as a number line. And let me try to bring up that pencil thingy again. So we have 0. Okay, at noon, it was 11.4. Okay, it decreased by 15.7. All right, so there's a couple of ways to do this. This whole leap here is 11.4, so that's going to be chopped off of that. So that means what's going to be left over here, right, is going to be 4.3. And it's going to be negative because we pass 0 onto the side here, right? Okay, so that one was more or less easy peasy. We could have done a thermometer. We could also do just regular subtraction. We started at 11.4. This is a way to double check this. Minus 15.7. And an easy way to do that is to flip these two. And you end up with the 4.3. And because you did the flipping of them, you'll get the regular math coming out. So because you flipped them, you have to negate it at the end. That's the way I normally do it. It's more convenient to me. Other people think other ways. Okay, so so in that case, in here, this case, the answer ends up being A. Okay, let me just switch in here real quick to see if anybody said anything. Okay, it's complaining about my visit. An error has occurred. All right, so this is not even running anymore. Okay, let me see here. No, it's still showing it going. All right, this is weird. Okay, it's shown to 4.3. All right, let's come back to this and see if it brings me back to here. I'll just keep this running on my laptop, my lap. Doug earns $10.5 per hour working at a restaurant. On Friday, he spent 1 3/4 hours cleaning, 2.5 hours doing paperwork, and 1 5/12 hours serving customers. What were Doug's earnings? Okay, so we have the amount he makes per hour. We have him doing various activities, and what is his total earnings. So in some cases we have to look at these deeper and kind of do that analysis that they're looking for the total earnings. So what we can do is we can take the 1050 and multiply it by the 1 3/4, the 1050 by the 2 1/3, the 1050 by 1 5/12, add them all up and get this joker's total earnings. I find that hard because there's a lot to do with. So what I'd prefer to do is to add up the fractions first, and then just do that last multiplication by 1050. The problem we have here is our fractions don't have the same denominators. So this is a common denominator problem indirectly. Okay. There's also other things. What I like to look for first, particularly as it relates to this here, I like to see if I can get something as a decimal first. Okay, so that could be 1.75. The problem is 2 1/3 and 1 5/12. They don't map into decimals directly. A third is repeating 0.333333, and so on. So that doesn't help us. So what we need to do is figure out how we can start adding these things together. So I noticed there's a 4 and a 3 and a 12, and adding fourths and thirds is going to give me twelfths anyway. So there's a couple ways to do this, but we could just jump in. So let me bring this up again. You know what I'm going to stick with. So you have 3/4 equals how many twelfths, right? So that's times 3 here. So we're going to times 3 here. We're going to get 9/12. Then we have a third. And for the same thing, how do we get it to be twelfths? We're going to multiply by 4. So this becomes 4. Okay, so what we're going to do is add up. Then again, we could tally this on the side. There's a whole bunch of ways to do this. What I'm going to do is I'm going to add up the whole numbers first. 1 plus 2 plus 2. That's going to give me 4. Okay, and then I'm going to have 9/12 plus 4/12. That's 13/12 plus the 5/12 here. So I'm going to get 18/12. Okay, now 18/12 is the same as 1 and 6/12. So there, times 1 plus 6. So we get 12, we get 18/12. So I have 4 plus 1 and 6/12, which gives us 5.5. Okay, that's 5.5 then. All right, I'm gonna plug this in to give me some power because my phone's gonna die. I have it running in parallel to make sure things are still going okay. Okay, so I'm gonna put that here. I think I just screwed something up on my phone, but let's see. Okay, so now what we have to do is multiply. I'm gonna bring up a calculator here. Oh, actually, I have to get rid of this tool first. So we have 5.5. Let me see if this works. Yeah, we have 5.5, and we have to take that, and we still have the $10.50 over here. Okay, so times 10. Oops, 5.5 times 10.5 equals, and we get 57.75, which gives us D. Let's see, how do I get rid of this highlighter? I guess it's not. You click on that, so we get D, and that's our answer there. Okay. Let me just make sure I got the right answer. Yes, 3 is D. Okay, so we'll go to the next one. Okay, what is the radius in centimeters of a circle that has a circumference of 16.7 centimeters? So we're going to bring up our pencil thingy. So, oh, by the way, the beginning of every state test. Let me get out of this for a second. Let me see. It's not letting me do that. Let me do one thing here. Close that. Okay, the beginning of a state test, the beginning pages has directions, as well as some of these conversion tables. So we can see here that we have the area of a circle is pi r squared. Circumference of a circle is pi d, or 2 pi r. Okay, so it tells us that the radius in centimeters of a circle is 16 pi. No, sorry. The circumference is 16 pi. So if we're trying to figure out the radius, we're going to have C equals 2 pi r. That's what we're going to be working with. Okay. Okay, let me bring this righty thing up. I don't know why they don't have a writing tool here, except they only have a highlighter. Okay, in any event, we get C equals 2 pi r. Okay, which means if we divide both sides by 2 pi, this will cancel out. We divide, whatever we do with the right side, we do the left side of the equal sign. So we have C over 2 pi equals r. And then we know the circumference is 16 pi. And we're dividing that by 2 pi. And we get 8. Okay, which should be A. Let me see that that's the right answer. Yes, 4 is A. So there's a temptation here when we see this to start trying to multiply by 3.14, or in some cases the 22/7. They haven't told us what to use, so for now you would use the 3.14. However, in this case, just leave pi alone sometimes until you get to the point where it makes sense to not use pi. So if you notice in this case, because when we got down to here, the pi's just canceled out. These canceled out. And we ended up with 16 over 2, which is 8. So we don't need to go and get something like 49 point something divided by whatever this came out to be, 6.28, right? We would end up with like 49 point something over 6.28, and that's the z-shaped thing is just going to give us something over here. That just complicates it, and we probably would have ended up getting something like 7.9999999. Okay, you could have done it that way. It'll still work. But the nice thing about pi is it's symbolic. It represents something. Pi is a constant, just like 4 and 5 are constants. Okay, so just use that to your advantage. Especially when you're talking about doing things algebraically. Some of you know some of your algebra already. Some classes have covered it. Certainly in grade 8 you should have had it, but some classes are still covering in grade 7. Hopefully they're done with it by the state test. But if you look at pi as the symbol x, even though it's a constant, it just means this thing. Okay, and when you don't need, and sometimes you get specific with things, and sometimes you can treat things generally. Okay, so just use the concept of pi until you don't need to. In some cases, you do need to finally use the 3.14 or some other representation close to it. In the meantime, the answer here is going to be 8. Some of the stuff you can do in your head once you understand some of the process. Okay. But it's worth double checking things and trying to figure things out. In fact, that might be, if you want to double check this by actually using 3.14, you probably could, because what we're going to get is, why don't we just do that real quick? Let me bring up the calculator here. Because we'd have 16 times 3.14. 16 times 3.14. That gets us 50.24, and we also had 2 pi, so 2 times 3.14 is that. So if we take the 50.24 divided by 6.28, we get 8. So we have a way to double check it. All right. Okay. Okay. So we're going to go to question number 5. Okay. We're done about half of this right now. Okay, so what I like to do when I run into a question like this is I don't look at the question. Okay, what I do is I just try to look at the chart that they give first. The illustration, the table, the information, the formula, whatever they're going, I don't look here, and I don't look at the answers or the question. What I'm trying to do is just analyze this. So I noticed, first of all, the whole thing is called quiz scores. Okay, it seems to be split in half. The first part, and then the second part over here. Okay, the first part has something to do with something about a first class period, and the second part has something to do with the second class period. Okay, now I'm finally going to look and see exactly what the thing they're talking about is on both sides. Okay, so I notice that they're line plots. So don't forget what a line plot is. Okay? This means that for whatever the 2 points was, there was one of those. Okay? On 3, there was 2 of them. For 4, there was 2 of them. And then equally for something like 7 over here, there was 4 people. So it seems to me, and again, I haven't read the question. I'm ignoring the question, I'm ignoring the answers, and I'm ignoring things they even gave me. I'm just trying to focus and look at this chart and understand this line plot and see if I can make sense about it. Because what I find is often when I do that and rip that apart and ask myself questions about it, when I finally get to what they're going to finally give me and ask me, I've already have the problem figured out. The other way around, looking at the given, looking at the table, looking at the answers, kind of rigs it so that you're starting to make the answers fit into the table. I'd rather understand the table in it as an entity and a thing by itself and ask myself questions about it while I'm going along, so that when I finally get to the questions and the statements they give me, I understand it all already. Okay, I know I just said that twice, but I think it's important enough to do that, and this is your approach. So the only caveat with that is what they do is when there's a thing, they give something here, and they also give something up here. Remember to keep this stuff up here. Don't know why they do it this way, but this is normally a tiny thing up here, and it's easy to just jump down here when you have to read the whole thing. So now that we have some understanding, we quite don't know 100% about it, but let's go back. Miss Andrews made the line plots below to compare the quiz scores for her first period math class and her second period math class. Okay, so these are scores. So apparently the top score was 10, and you got from 1 to 10. So it seems like nobody failed. Just looking at that now that I understand it, and what I'm going to do is take all this a sentence at a time, maybe even a phrase at a time. Okay, so I'm only looking at the first sentence so far. So it seems to me with that little information, I analyzed it first and reading it first, it seems like the second class, the second period class did better. The lowest person got a 50, and a bunch of people got 90s. In the first period class, somebody got a 20, and the highest somebody got was a 60. So it seems like the second period class has done better on this test than the first. Okay, so Miss Andrews gave the line plot below to compare this quiz and the physical. She gave the same quiz to each class, so it's exactly the same test. Okay, so now given that, what conclusions? So what I'm going to do is I'm going to clear all these lines because I'm going to bring this up slight. Actually, let me see if it's on your screen. Yes, it's on your guys' screen too now. So what conclusions can Miss Andrew make about the performance of her first and second period classes? Okay, so the first period class has a higher median score than the second period class. Okay, the second period class has a higher mean than the first period class. The first C says the first period class. Scores have a greater range than the second, and the D is the greater mean absolute deviation. Okay, so what we have is a whole bunch of numbers going back to either third or fourth grade that you only probably visit once a year, especially when you do the state tests, where they throw one of these questions in here based on that. So we have a bunch of terms. We have median, we have mean, we have range, we have absolute deviation. So each of those is a different thing based on a list of numbers. So if we just take the first period class, where there's a 2, there's 2 3s, 2 4s, 2 5s, and a 6. Okay? So since they're talking about the median is the middle number of those. So if we line it up as 2, 3, 3, 4, 4, 5, 5, 6, okay? It turns out if we go back and forth, if we cross them off, let me bring back my my thing here. So if we go here, that matches with that. We can go back and forth. These two match with this, and it turns out the middle would be between these, which is going to give us a 4 on both of them. Okay. So we get the median between 4 and 4. So it turns out the first class median is 4. We have to do the same thing here. So it turns out if we go back and forth, the second class median is going to be a 7. Okay? That's different than the mean. So the first period class has a higher median score than the second? No. So it's not A. Okay? A fails that test, whatever we're calling it. Give me 1 second. My phone is freaking out. I'm not sure why. I think it has to do with the way I'm powering it. My cable's screwed up. Okay, so B. The second period class has a higher mean than the first period class. Okay, mean is different. Mean means actually taking each of those numbers and adding them up. Okay, so if we do that quick, okay, so let me get rid of this. I'm going to get the calculator. We're just going to start adding them all up. So we have 2 plus 3 plus 3 plus 4 plus 4 plus 5 plus 5 plus 6, and we're going to divide that by the number of things we had. So we have 2 plus 6, there's 8 things. So that gives us 26.75. Okay, we're going to do the same now for the second period. We're going to get 5 plus 5 plus 6 plus 6 plus 6 plus 6 plus 7 plus 7 plus 7 plus 7 plus 8 plus 8 plus that's going to mess up. All right, let's just do it a thing. We have 10 plus 6 times 4 is 24 plus 7 times 4 is 28 plus 8 times 4 is 32 plus 2 times 9 is 18. So we're going to get 112 divided by, that's 12, 13, that's 16 things. So we have 26.75. And the average of this is 7. Something tells me that's wrong. Oh, wait a second. We didn't do the division on the other one. So we have 2 plus 6 plus 8 plus 10 plus 6. We got 32 divided by 1, 2, 3, 4, 32 divided by 6. And we get 5.3333, whatever. So the second period class has a higher mean than the first period class. That turns out to be true. Okay. See, but we're gonna be thorough here, especially if you're gonna be double checking these and so on a real test. The first period class scores have a greater range than the second period classes. The range means taking the lowest number and the highest number of each set and subtracting them. So the range for class 1 is 6 minus 2 is 4. The range for the other class is 9 minus 5 is 4. So they're both the same. Okay? So it's not C either. And then D says the second period class scores have a greater mean absolute deviation than the first period class scores. So mean absolute deviation doesn't come up very often. In fact, it hardly comes up at all. What it means is taking the mean. In the case of the second period class, I think we said that the number was actually somehow that 5.33 seems wrong. In any event, the answer still B if you actually do the calculations. If you total it up and do it, you should still get that number. 2 plus 6 plus 8 plus 10 plus 6 is 32. Yeah, it was 32. It was 32. It was 32 not divided by 6. It was 32 divided by 8. So it should have been 4. So 4 is still less. And then even going back to D, what we're going to do is get the average of the second class period, which is 7. I think that was the number we came with. And we're going to compare it to each thing and subtract all those and add those up and do the division again. And we get another number. Turns out that number is off. Okay? All right, so that's B. Okay, question number 6 deals with probability and statistics, that section of things. So if we just look at the chart, it says we have a number pyramid and we have a spinner. The spinner apparently has 3 colors, and the number period apparently has 4 numbers. Okay, what a number period basically is think of a dice, a cube, where you roll it and it has from 1 to 6 on it, and you toss it about. So imagine instead of having 6 sides, it only has 4 sides. So imagine a base of a pyramid, a triangular pyramid. Okay, that has 3 faces and the base. So there's only 4 sides to it, and each side is numbered. So now that we understand that, so there's 4 choices there, and there's 3 for the spinner. So it says Henry has a fair number pyramid, and what a fair number pyramid means it's not loaded. Normally, when you're getting back to a normal cube dice, if you roll it and one side's too heavy, it's going to maybe come up with the number 6 all the time and the number 4 all the time. So a fair cube means it's equally weighted on all sides. So Henry has a fair number pyramid. So in that case, there's no shenanigans going on with it. He has a fair number pyramid with 4 faces and a spinner with 3 equal size colored sections. So the chance of the number pyramid landing on 1 to 4 is a quarter, and the chance of the spinner, because there's no shenanigans going on with that, is 1 to 3. So we have a quarter. So when we have a scenario like this, what's the possible outcomes for each as shown below? Okay, what is the probability that the number pyramid will land on a 3 and the spinner on a blue? So we just spoke about that. The chance it will land on a 3 is a quarter. It's 1 out of 4. Okay, and the chance the spinner will land on a blue is 1 out of 3. And since it's together, what we're going to do is multiply the two of these. So we're going to get a 12th. Okay? And these problems often just work this way. You just get the probability, what happens to be, and you do the multiplication. Okay? So the answer here would be A. All right? And if it said for instance, what's the chance that it landed on a 3 and a blue and a green, it would have been a quarter times 2/3. Okay? And you would have got 2 12ths or a 1/6. Okay, so question number 7. Okay, this one gets nastier. So this is a show your work one. So the sampler is kind of varying back and forth. So it says Graham's monthly bank account showed the following deposits and withdrawals. So there's 5 comma separated numbers there. And we have to do something with them. So it seems like we should conclude that a deposit is a positive number and a withdrawal is a negative number. So for instance, minus 2204 means that was money taken out, and 9411 was money put in. So we have to assume, based on that the account was starting from 0, and we just add and subtract till we go there. However, we note that it says his balance started with 47.86 at the beginning of the month. So what was the account balance at the end of the month? So this means taking all those numbers and popping them through there. They want you to show your work, so basically you're going to write all the stuff out. Let's see, can I do? Yes, I can do here. So I'm going to have 47.86 minus 25.20 plus 52.75 minus 2204 minus 850 plus 9411. And if we just chuck them into the calculator, be careful with the calculators. 47.86 minus 25. This thing wipes out the whole thing. 47.86 minus 25.5 plus 52.75 minus 22.04 minus 8.5 plus 94.11. By the way, if you notice, I'm just putting 8.5 and 25.2 because the zero is really not going to matter. And we end up with 138.68 if I type that in right. What I like to do is, when I do stuff like this, I went through the numbers forward. I wouldn't mind going through them backwards just to double check that it's actually 138.68. And then you put in your answer here, 138.68. 8 at 68. What? I put comma there. All right, and that one's pretty much straightforward that way. So this one's worth 2 points. The previous one was worth 2 points too, I think. Did we just do a... here, let me go back to the question number 6. No, so this is worth 2 points. Question number 7 gets more involved. It's more nasty stuff. This is 2 points as well. So a pine tree measured 40.5 feet tall. Over the next 7.5 years, it grew to a height of 57 feet. During the 7.5 years, what was the average yearly growth rate of the height of the tree? So let's figure this out. It started out at some point. It was 40.5 feet. It over 7.5 years, it grew from 40.5 to 57 feet, and during 7.5 years, what was the average yearly growth rate? So I mentioned something earlier. These are all halves. So I think I'm going to use 40.5, 7.5, and 7.5, just because that's probably going to work out. So what do we have to do here? Let's see. So first of all, we need to see how much it grew. So if its current height is that, and this is 40.5, okay, that's going to be 16.5, I believe, right? Yeah. How much it grew. And if it did that over 7.5 years, so then we're now going to divide that by 7.5. Okay, I believe that's what we're doing here. Let me just reread it. A pine tree measured 40.5 feet tall. Over this next 7.5 years, it grows to 57 feet. During the 7.5 years, what was the average yearly growth rate of the height of the tree? Right, so the average yearly growth rate. So we're going to have 16.5 divided by 7.5. And we get 2.2. Okay, I'm not sure why they gave such a giant space there, but in any event they did. They do give us this already here. Feet per year at the very bottom. Just always be aware of units if they don't give you that you need to put that in yourself. Okay, so this one actually wasn't too bad. So you're going to get a point for showing your work and knowing how to do it, and then another point for actually getting the answer right. So in questions like this, don't leave it empty if you don't know what to do. You can still get the answer wrong, get partial credit. That's the point of this. With the multiple choice, it's you either got it or you didn't get it. On these, it's slightly different, that you do have a shot to get partial credit. Obviously, you should try to get full credit, but when you can't, there's no other choice. Okay, the next one, question number 9, this is worth 3 points. So what we have is a show you work thing and an answer thing. So Mrs. Hamilton worked for a real estate agency. So I'm going to take this a sentence at a time. She sold a house for $175,000. The agency's fee for the sale was 4% of the sale price. Okay? We may or may not need to use that information. So let's just talk about it though, and let's see where things go. The house sold for $175,000. Okay? The agency fee was 4%. All right? That's pretty much straight up it. So why don't we actually do that? And again, in the real example, you may or may not want to do it, but you're just trying to understand the problem at this point. So we have 175,000 times 0.04. Okay, and we get $7,000. Remember, percent means divided by 100. So 4% means 4 divided by 100, which means as a decimal, 0.04. Okay? So that's where I get the 0.04 on the calculator from. All right, so we have that the agency fee was $7,000. Okay, Mrs. Hamilton receives $47.25 of the agency fee as her commission. Okay. And we're taking this a sentence at a time. Okay, what percent of the agency fee did Mrs. Hamilton receive? Okay, and round your answer to the nearest tenth of a percent. So what do we do next? The agency got $7,000. She got $47.25 of that. So what percent did she receive? So what we're going to do is do $47.25 divided by 7,000. So bring that up. 47. Whoops. Let me slide this over. We're going to get equals 0.675. Okay, which means 67. Whoops. 0.5%. Okay, if I did those numbers right, that's what that should be. I'm sure if I did it wrong, somebody's going to double check me here. So and then it says round your answer to the nearest tenth of a percent. So that seems to be the case. So let me just double check some of this. So we have 175,000 times 0.04. I did that wrong. 75 times 0.04. We get 7,000. We get 47.25 divided by 7,000. And we get 0.675, which is 67.5 then. And at least on the online thing, we did all the answers here, and it's going to let us submit the test. Okay. All right, so that concludes this video. Again, what we're going to do is take little bite-sized pieces of some of this and go through different parts to give you a sampling of what's happening. Again, this is actually representational questions from the grade 7 test. We'll do a few more of these on some part 2 and part 3 and part 4, and including the grade 8. And then that might lead into actually doing SHSAT material as well, and maybe actual past grade 7 and past grade 8 tests, just to start building up. And because the state test, again, today was the ELA test, so in about a little over a month is going to be the state math test, and then in the fall is going to be the SHSAT test. There's also other tests. Some of this can be enjoyable and fun and whatnot. Again, my email's on the bottom, GregsTutoringNYC@gmail.com. I hope everybody has a great day. All right, and peace out.